Okay, so this video is to do some clarification for the group project IPR2 lifecycle costing section. So I believe that everybody's got a pretty firm foundation on how to develop candidate solutions through idea generation, alternative generation improvement. But when we get into lifecycle costing, it seems like there's some points that need to be clarified. So through this video, hopefully all those points are clarified. If for some reason you have questions, feel free to contact me by email or to stop by the office during AI hours. All right, well, let's get after it. So in the group project, we have to do lifecycle assessment. And the way we do that is that we add up or sum all of the costs associated with each candidate solution. So by the time you've developed candidate solutions, which should be a minimum of 3, you need to assign cost to them. And if you look at the slideshow presentation from the project launch, we've got acquisition infrastructure costs, which include these security things like and quarters, as well as generators and then latrines. These are one-time costs. And then we have operating costs. We have rent, generator, and fuel and service costs, latrine costs, and then food service. So right up front, rent and food service costs are not provided in the lifecycle costing sheet. So you do not need to include them in your lifecycle cost assessment of each candidate solution. But everything else is. Everything else is included on the lifecycle costing sheet, which is shown here. So this should look familiar to you by now. Let's go ahead and start in the upper right-hand corner here. We've got the combat outpost acquisition costs. The acquisition cost includes all of the construction, right? So assume that it includes all of those rent rates that we said earlier. And depending on the size of the COP that you build, 1 to 2 platoons, 3 to 4 platoons, or 5 to 6 platoons, it has a cost and a time to build that COP respectively. So depending on how many COPs you build, they're going to eventually cost, or the first one will cost this much amount, and it will take this much time. Now, if you build more than one, which obviously you will, because each course of action should have between 3 to 5 COPs, the cost and the time it takes to build them goes down according to the learning rate function that you learned in class. And when we say here, assume a linear relationship between time decrease and cost decrease after the first COP is built, what we're saying is that you can use the learning curve formula to calculate both the decrease in cost and both the decrease in time and the decrease in cost. We have these other one-time costs of generator, latrines, and construction materials. Just make sure you pay attention to units here. So if you have 4 platoons on a COP, and it says you need 1 generator for 3 platoons, that means that COP needs 2 generators. Same thing with latrines, right? There's 2.5 latrines per platoon. This should be some sort of whole number, right? So if you have 2 platoons, you should have 5 latrines. But if you have 1 platoon, you should have 3 latrines, which should make sense. Then, of course, each latrine costs $5,000 each. And then, of course, construction material is $2,500 per platoon at each COP. So that's a multiplicative factor. The other thing that's important is this bullet point down here, how you incorporate the ANA. If you augment the ANA camp with additional forces, you need to include those costs per the description here. You can also include ANA platoons on your own COPs, but they need to be counted in this number of platoons. So obviously your costs per COP will go up depending on the size of the COP and how many platoons you have on each COP. So it's not just enough to say that you have 3 COPs in a course of action. You have to be specific as to how many platoons are at each of the 3 COPs. Okay, then we have these operating costs, and these operating costs are recurring costs that happen every month, right? So when we say week here, just convert this weeks to month by multiplying by 4. I'll show you how we do that here in a second. And then we also have included these SERP funds, right? So you're given a budget of $45,000 to spend over the year. And we want you to tell us how you're going to spend that. So tell us which projects you're going to choose over the course of the year. There should be a different set of projects chosen for each candidate solution. You shouldn't have the same SERP projects for every single solution. We're not to the point yet to be able to develop the ultimate solution, so we want some variation in our choices. So choose different sets of SERP projects. Of course, your aggregate or your total amount being spent will be $45,000. Okay, so let's look and see how this is done, carrying this information like the learning rate and these values forward to an example. Okay, so the first thing we do is our learning rate calculations. And in this example, I'm building 5 COPs. And I'm saying at each COP I'm going to have 1 platoon. So I'm going to build the 1 to 2 platoon size. Clearly, you're going to have more than one platoon per cop, so just make sure that you adjust your numbers accordingly. So I've got 5 cops, of course, my learning rate of 72%. The first cop costs $55,000 and it takes 12 hours. Now, if you see here, on the first row here, I've got 1 through 5. I can see that the time that it takes is 12 hours and it costs $55,000. So it begs the question, what do cops 2 through 5 cost? Well, we apply our learning curve formula, as you can see here up here in Excel. It takes the same form from what you learned in class. If you remember, the form is T sub x is equal to T sub 1, so this is x there, times x raised to r, and r takes the form of the natural log of your learning rate divided by the natural log of 2. And you can see that up here this Excel formula matches that same value. So for example, the second cop, we have C29, which is T sub 1, times B30, which is the number cop, raised to r, and r is the natural log of 72, our learning rate divided by the natural log of 2, which gives us a value of 8.6 hours. And then we do the same thing for cost. The only difference here is that the cost subs T sub 1 for the dollar value. So you can see that the cost to produce the cop is reduced accordingly. Then all you do is you, just like in Excel, you grab this little guy here, and we pull it down and it leaves us these costs. And then we have our total hours to make all 5 cops, and our total cost to make all 5 cops, which is the sum of all the values in for each cop. So each cop's cost summed together gives us the total cost of all cops for acquisition. All right, so how do we incorporate that into our life cycle cost? And this table here represents our total life cycle cost. We'll end up here with a present value, which I'll explain here how we get there. And here's our assumptions, right? I said that we have 1 platoon at each cop. So 1 platoon at each cop requires a 1 generator. Generator costs $45,000. There's 2.5 latrines required per platoon. So that's 3 latrines because we're rounding up. The materials for 1 platoon is $12,500. And so these 3 numbers added together give us this value up here, 72,500, and then multiply it by times 5 because we're making 5 cops. So the total number of cop construction costs for security is equal to 362,500. And then you can see over here my cop construction, this number is referenced directly from our learning curve formula down here. So I have these 2 values together, which give me the one-time acquisition cost. Then we have our reoccurring cost, our monthly cost. And you can remember from class, if we have costs that are incurred between times 0 and 1, we carry them forward to the next time period. So we carry them forward to time 1. So where does this $3,510 come from? Well, it comes from down here. You can see that we have a fuel charge, right? This is that 90 gallons times 4 weeks, which gives us the amount of gallons per month, times 475, which is the rate that it costs to purchase the fuel. And then we have $800 per month for service for latrines, and then $1,000 per month for service for generator maintenance. And so if you add all those together, you see we have $3,500 per month in operations and maintenance costs for each cop. And that is true for the entire year that we're there. Speaking of which, this time period over here, these are months, which you'll see is important here in a second, because after we talk about SERP funds, you'll see that we're going to discount monthly cash flows back to time 0, which is our initial time, so that we can have a present value. And our discount rate will be discounted at 1% per month. Okay, so SERP funds are unique because each course of action or each candidate solution should have its own allocation for SERP funds over the year that you're there. Decide which projects you're going to do for each candidate solution, and then according to the lifecycle costing sheet, you'll see that each option has a time period associated with it. It's got potential value. If you haven't included a value function, this may be a good place to adjust it. And a cost, right? So you can't do 3 classes at the same time because there needs to be a 3-month spread between each class that you hold, right? And so, for example, if this is the only SERP project you do, this training team governance admin class, right? You could do 3 of these classes total, and that would soak up, 15 times 3 is 45. It would soak up all $45,000 of your money. So you can see how you may want to select water purification or road upgrade. That'll all depend on your interviews and your stakeholder analysis. Okay, so what I've decided to do is to spend $30,000 up front, and then after a 3-month period, I'm going to spend $15,000, and then this money is allocated through whatever selection of SERP projects I've decided to do. Okay, so now that I've got total cash flows for each time period, I can highlight here. These are all the different categories of costs for each time period. When you highlight a series of cells in Excel, it does this sum down here for you. You can see that it's $5,700 in costs for time period 0. That's all the money I'm going to spend up front. If I come over here to cash flows, I can see that this number here is the same as the one that was down at the bottom of the screen. So what I've simply done is give a sum function that sums all of the costs for a particular time period. Okay, once I've done that, I just do the same thing that I did down the learning curve. I just grabbed this and I pulled it down, and that gives me all of the costs that are associated for each time period. Now that I have all the costs for each time period, I can discount those time periods and get the discounted value. So I use, and this should look familiar, this discounted cash flow formula. The cash flow is up top, right? The sum of all these values divided by the discount factor, which is 1.01, because we're discounting here at 1% per month. So it's 1 plus 0.01, and it's raised to B3, which is the time period. And of course, this is time period 0, so any value raised to 0 is 1, so the present value is equal to the total cash flow. Then I just do the same thing. I grab it and I drag it down, and all these values will populate with discounted cash flows over the course of the year, discounted at 1%. And then to get the net present value, I simply sum all of the present values for each time period, and that gives me the net present value calculation. Pretty straightforward. You can see that this allows you to incorporate all the costs, all the normal costs, plus the opportunity costs incorporated here in this discount rate. And so I should see a unique net present value for each candidate solution, right? And each solution is going to be different because you're going to have different numbers of platoons at each COP, which will require different amounts of infrastructure. It'll be different based on how you allocate the ANA. It'll be different based on if you have 3 or 4 platoons at a COP as opposed to 1 or 2. And so these numbers should be unique, right? You shouldn't have similar present values for every candidate solution. They should be distinctly different. And then not to mention your SERP funds should be different. So then depending on where you allocate them over the year, just by virtue of discounting, you'll end up with different values. So each candidate solution should have a unique net present value. So there's only one other thing that should be included. You should have cash flow diagrams for each of your candidate solutions. And so if this table represents a cash flow a present value calculation for a candidate solution, what we want to do is look at this total cash flow, and this total cash flow column gives us the basis to make our cash flow diagram. You remember we have our cash flow diagram, which goes from 0 all the way to 12. And those are months, right? 1, 2, 3, 4, ... And then we just simply take the values from here and put them over here. So for example, in time period 0, we have a negative cash flow. That's what these parentheses mean if you haven't seen this notation before. Parentheses. That means negative in Excel. So anytime you see a value in parentheses, it means a loss. So we have a negative cash flow of 573, and then you would do the same thing for each time period. ... all the way through to time 12. Right? And then you would say my interest rate per time period is equal to 1.